Okay, so this is going to be what we're doing until Christmas break. And so this will be function part B. You guys already did function part A. This is function part B. So this is what your packet should look like. You should already have it. I'm just going to kind of explain briefly a little overview. For the month of December, it's kind of weird because of our days that we land on. So those of you who are on first, second, and third period, you are going to have to do things a little bit different, and you're going to have to really pay attention, and you're going to do the function notation exit ticket. So here we go. Here is kind of like what you're going to do right now. Here are little notes on what is a function notation. So a function notation, that's this part right here. Function notation is just a way that we're going to write a function. And that's meant it's a precise way of giving information. So we usually use F for function. Sometimes we use the letter G, sometimes the letter H, but we usually use F for function. And then that X value is what we're going to put into that X. And then this is going to be our rule or whatever that is, whatever kind of like our equation. All right, so some quick identities. So in this case, what happened, and if you notice, right here, I have two functions. I have three different functions. I've got f of x, and then I have another function. I have g of x, and then I have the other function, which is h of x. So I have three different functions rules right here. And so basically what happens is whenever I see the letter h, I know I'm going to use the function h. So I just go through and I highlight all of my h's, so then I know what's going on. Then I'm going to go through and I'm going to highlight all of my f's, all my function f's, and so then I know I'm going to have that, and then I'm going to go through and I'm going to highlight all of my function g's. Okay, so now I'm color coded it, and it's a lot easier for me to figure out, okay, what do I actually need to go through and do. So for function f, so when we go through and we're going to do function f, we're going to substitute in, because this 2 is going to go into that. So you're going to have -5 times 2 plus 7. Because 2 is, now that we're inputting 2 into that. So -5 times 2 is -10 plus 7. And -10 plus 7 ends up being -3. So this says when x is 2, the value is -3. So this answer is -3. There's a negative sign in there, believe it or not. So f of 2 is equal to -3. So because I'm already doing function f, I'm just going to go through and I'm going to find my other one that says function f, and I'm going to go through and use that. So now we have f of 5. So when x is 5, so -5 times 5, because this part I'm inputting that 5 in, and then plus 7. So -5 times 5 is -25. And then plus 7, and then we just use, and you go ahead and use your calculator, that's perfectly fine. -25 plus 7 ends up giving me -18. So this says when x is -5, the function's value is going to be -18. And that's my answer right there. Again, we're going to do this other one that's when f of 1 is -1, so we're going to plug -1 in for x. So I have -5 times -1 plus 7. So 5 times 1 is 5, and a -5 times a -1 ends up being +5 plus 7. So 5 plus 7 is 12. So when x is equal to -1, the function's value is 12. So all I'm doing is writing out what it really means, and the reason why we go back and we use that function notation is because that part that I've circled is a lot easier to write than writing that little sentence. When x is equal to -1, that function value is 12. It's a lot easier to write the other one. So now we're going to look at function g. And now we're going to use function g, and that x is an exponent. So gotta really pay attention to this, and this is where you're going to definitely use your calculator. So when you're going to go 20, 0.5, so 20 times 0.5 to the first power, because that x value is 1. So 0.5 to the first power is 0.5, and then times 20, so half of 20 is 10. So when x is 1, the function g, the g's value is 10. So this ends up being 10. So when x is 1, when I input 1 in, then that value is 10. So I'm still doing function g, so I'm going to go find another one. Now I'm going to use g of 0. So now I have 20 and then 0.5 to the 0 power. Now this you might remember from middle school, you might not have, but you did this at the beginning of 8th grade, according to Mrs. Abarno. Anything to the 0 power is 1. So that is 1. 0.5 to the 0 power is 1 times 20. So that initial value, this is kind of like your y-intercept, that initial value is 20 times 1 is 20. So when x is 0, the function, value is 20. So g of 0 is equal to 20. And again, we're going to do this one down here when we have g of 10. So g of 10. So we have 20 and 0.5 to the 10th power. Now, this is not something that I would ever do without my calculator. So I'm going to go, and this would be 20 times, and I'm going to go 0.5, and then I have a caret up button, and the caret up button looks like this. And on your computer screen, it's shift and then the number 6 on your computer screen. And then you just type in 10. So 0.5, and then you're going to get some scientific notation. So this is 0.9765, and then times, whoops, I messed that up. Wait a second. Hold on. So this ends up being 9.765625 times 10 to the -4 power. Because this is a really small number. That's a very, very small number. It's getting closer and closer to 0. And then what I do is I just take that and multiply by 20. So this is, again, review of your, from the beginning of the year. I think you could do this in September or October last year with Mr. Churchill and Mrs. Abarno. When you did this, and you did scientific notation, and you did exponents. So this ends up being 0.01953125. So that's where you're going to get this. So this would be your amount. So when x is 10, the function's value is almost 0, 0.01, and then I'm just going to round this to 0.19. Okay, so this ends up being 0.019, and that's going to be your function. So that's going to be when x is 10, So when I input 10, my output gets 0.019. And then now we're going to go through and we're going to do this again, except this time, now we're going through and we're using function h. So function h is a little bit different. So I'm inputting 4. So we're going to go up here to the top. I'm going to input 4 in for x. So this will be 4 squared minus 6. And one of the rules that I like to do with 4 is I like to put it in parentheses, because if you have a negative number, which we'll get down to a -3, we'll forget. So 4 times 4 is 16, and then minus 6 ends up being 10. So 16 minus 6 is 10. So again, when x is 10, when x ends up being 4, the value is 10. So this ends up being 10. Okay, and then we're going to do it again, and this time we're going to input 2, and then we're going to figure out what our output is. So 2 squared, and then minus 6. 2 times 2 is 4, minus 6 ends up being -2. So 2 times 2 is 4, and then you have that minus 6 that's still there, and 4 minus 6 is -2. So when x is 2, the output is -2. Or that function's value, if you want to put that instead. Okay, next part, the very last one that we have, when we're going to input 3 in, and this time it's a -3. So this is why I put in a -3 in, and I square it, minus 6. Because what happens if you don't put that -3 in parentheses and you put it in your calculator, it's going to read the PEMDAS rules. It's going to read 3 squared. So negative hangs out, and 3 times 3 ends up being 9, and then there's that negative sign. So that's what happens when you don't do parentheses, but this is not right. So 3 times 3 is 9, and a negative times a negative is a +9 minus 6. So 9 minus 6 ends up being 3. So my input is -3, my output is +3. So when x is 3, the output or function's value it's hard to write with my little stylus. Sorry, guys. Is 3. So when that x value is -3, that function's output value is 3. And then that's basically what you're going to do on this whole part, and then you have homework. So that's this first one. That's what you're doing for your homework. You're just going through and you're figuring that out. You're going to input something, and then you're going to put something, you're going to put it in a function machine, and then you're going to put something to get the output of that.